Lecture 5, Thickness using Linear Algebra. In the previous lecture, we looked at several formulas for determining the thickness of a layer under different situations. In this lecture, we will derive a general solution to this problem using linear algebra. Suppose we have a topographic, Cartesian coordinate system, east, north, up, here shown by the black axes E, N, and U. Suppose we know the east, north, and up coordinates of points on the top and base of a sedimentary layer. We can transform the coordinates of these points from the east, north, up coordinate system, to a strike, dip, and pole coordinate system, here indicated by the red axes S, D, and P. The thickness of the layer can then be calculated by subtracting the pole, P, coordinates of points on the base and top of the layer. To transform from the east, north, up coordinate system, to the strike, dip, pole coordinate system, we need a transformation matrix, A. This matrix is a 3 rows by 3 columns matrix, with components equal to the cosines of the angles of the new axes, S, D, and P, with respect to the old axis, E, N, and U. For example, A, 1, 1, is the cosine of the angle between the strike axis, S, and the east axis, E. Without demonstration, the matrix, A, for this transformation is given by this equation. Notice that the components of the matrix are functions of the strike and dip of the layer. Now that we know the transformation matrix, A, we can transform the position vector of any point as V' is equal to A times V. Or in index notation, V'I is equal to Aij times Vj. This second way to write the equation is known as the Einstein summation convention. In this convention, whatever subscript is repeated on one side of the equation is known as the dummy suffix, in this case j. The summation within a single equation always occurs with respect to that suffix. The free suffix occurs only once on each side of the equation, in this case I. There will be as many equations as there are values of the free suffix, I, and each equation will have as many terms as there are values of the dummy suffix, j. Expanding this equation gives 3 equations, each one with 3 terms. These 3 equations allow us to compute the components of the vector, in the new coordinate system. Notice that V'I is the coordinate of the point along the pole axis, P. If V't and V'B are the S, D, and P coordinates of points on the top and base of the layer, respectively. The thickness of the bed is given by this equation. Thickness is equal to the difference of the pole, P, coordinates of these points. We will do this exercise in class using this procedure. Notice that in this problem, the units have the same strike and dip, and points 1 to 5 are at the contacts between the units. To better understand these concepts, please read these sections from our Computational Geosciences resource. And answer this question.